We've seen this slide a couple of times now, but it's just to remind you what we're actually doing. So we're looking at factors that affect reaction rate. So we've already covered how temperature affects the reaction rate, and we've also looked at how the amount of the reactants affects the reaction rate. These two factors here are factors that have to be controlled during experiments where we're looking at the concentration of reactants. So concentration of reactants also affects the reaction rate, but this is the part that we're actually looking at or are interested in when we carry out our internal assessment and our formative assessment, which also can get you 2 credits. So we're going to be focusing on this one now. So this is going to become our independent variable, and these two things here are going to become our control variables. So I'm going to talk you through how we're going to do that. Okay, so as we do this experiment, which can get you 2 credits, you are going to be considering how increasing the concentration of the reactant changes the rate of the reaction. And you also need to keep in the back of your mind the 2 things you're controlling, which is the temperature of the experiment and the amount of the reactants that go into it. So to access the planning sheet for this, you can get it out of the bag, which is labelled Formative Assessment, Unit Standard, or you can go to Google Classroom if you're going to use the digital version, and it's in this Learning Objective Drag and Drop Notes post, which should be at the top of your screen, and then you go to the very bottom attachment, the task sheet, which has all these numbers in front of it. So because this one here gets you 2 credits and is also going to be useful for your internal assessment, there are different rules around how you do it. So make sure you listen really carefully to the video instructions so that you know what's happening. So for this assessment here, you're going to follow the instructions to carry out a practical scientific activity and then report on that activity. So you'll carry out the plan or the method below. You'll record and process your results, draw a graph, and then write a conclusion for the experiment that links the results to the purpose. This step here, you can do that as a group. So you're going to carry out the method as a group and gather your data as a group, but these 2 steps here you must do by yourself without talking to anybody else. And also I can't help you with those. So make sure you follow the steps carefully. And I'll explain them first of all, but then once you've had them explained, you have to go off and do it by yourself. So the purpose is to determine how the rate of a chemical reaction changes as the concentration of solution B is changed. So this is what we're actually trying to work out. So we're trying to work out how the rate of a chemical reaction changes as the concentration of solution B is changed. So we're changing the concentration of solution B. That is our independent variable. And our dependent variable is the rate of the chemical reaction. Now for this assessment here, because it is a formative assessment and because it is a unit standard, you don't have to fill out the planning sheet. However, I want you to write this method here, or the procedure, all the way down to this point, where it says step 9, into your science book, or if you're using a digital version, then you need to copy it into a new doc. And I'll explain the reason for why that is in a second. So we're just going to copy it over. We're going to make a new document if you're doing this digitally. And we're going to paste it in. And we're going to call it Method for Unit Standard. Now if you're doing this hard copy and writing it out, you need to write it into your book and you need to write the title above it, Method for Unit Standard, so that you know what it is. We're now going to expand this method in your own notes, not on your task sheet, not this one, but here in your own notes so that you've got it for you when you do the real assessment. Okay, so step 1 is collect the experiment kit. So that's fine, we don't need to make any changes to that. We need to then rinse a 50ml beaker and place it on top of a piece of paper which has an X marked on it. Why should we rinse out the beaker first? Well, we should rinse it out because if we don't, it might contain chemicals already that affect our results. So we're going to put that here. I'm going to make it a different colour so that we know that it's been added in. But you also, in your own book, might just want to draw an arrow off so that you know that this is an extra note. So we'll say we rinse the beaker first because it might contain chemicals that will affect our experiment. Okay. Into a measuring cylinder labelled A, so you'll need to label a measuring cylinder with A, measure 10 mils of solution A, and then pour this into a beaker. So we're going to add here how we measure out accurately 10 mils. So it's told us that we're going to use a measuring cylinder, but what do we have to remember when we're using a measuring cylinder? We have to remember about parallax error and about the meniscus. So we're going to say, make it blue, as we are using a measuring cylinder, we need to avoid parallax error by crouching down to look at the bottom of the meniscus at eye level. Okay, so that's telling us why we need to be accurate in our measurement and how we're going to actually be accurate in our measurement. Then we measure out 10 mils, which is 100% of solution B, into a measuring cylinder labelled B. Again, we have to avoid parallax error and look at the bottom of the meniscus as we did for the previous step. So we'll just put avoid parallax error by following step 2. Because we've already said how we're going to do it, but we can just need to make a note that we need to do that as well. Pour that into beaker and start the stopwatch as you do this. So we don't need to make any changes there, that's fine. We're going to time how long it takes for the X to disappear in the cloudy solution. So a cloudy solution is going to form, and we're going to time how long. Stop the stopwatch when you can no longer see the X and record the time in seconds on your results table. Now when you do this experiment for the first time, you'll notice if you look at it from the side, compared to looking at it from the top, the X might disappear at different times. So we need to state how we're going to look down at the X so that we keep it the same each time, because we don't want it to happen at different times, we want to happen at the same time for each trial. So I'm going to say, we will watch for the X disappearing by looking down into the beaker from above it each time. So this is how we're making sure that it is a fair test. So we're going to watch by looking down on it. So when you carry out this experiment, make sure that that's what you do. Alright, tip the mixed solution down the sink. It will smell, so make sure you rinse it with cold water. And then you're going to repeat steps 2 through to 7 using solution B that's been diluted to 80%, 60%, 40% and 20%. You're going to use some water, and you can just use water from the tap, to make up your solutions to 10 mils in a measuring cylinder, and you use this following table. So you've already done your 100% concentration of B. So that was using 10 mils of B. So we've already done that one. So you're going to start here now for your next step. So when you repeat the experiment for a different concentration of B, you will be putting in 8 mils of B, and then you'll be putting in 2 mils of water into your measuring cylinder, and that means you'll have a concentration of 80%. You will, for the 60% concentration, need 6 mils of B and 4 mils of water into the measuring cylinder for B, and then that will give you 60%, and so on for 40 and 20. Now down here, the last step, step 9, to add to that, it says repeat each trial 3 times for each concentration, then average the results and remove any outliers by repeating the experiment. Sorry, we'll say trial. By repeating a trial for if necessary. So that's just saying that we're going to repeat if we need to, because we might end up with some funny results, and that we're going to average the results so that it makes it a fair test. Okay, so make sure that you have these notes somewhere written into your book, because you can use it for your internal assessment, your achievement standard, which will get you 4 credits. And it just will get you a higher mark, hopefully, if you've included all these points and are deemed to be valid.